In 11.3, we're going to look at properties of logarithms that help us either expand or contract log equations. And so we're going to start with the first one. These that you're going to see are pretty similar to actually the properties of exponents. But when you have log base b of m times n, so when you're multiplying two things, you can actually break this up into two separate logs. So this can become the log base b of m plus the log base b of n. And you can use this equation in either direction. So sometimes you have two things multiplied together and you break it up into two separate logs, or you have two separate logs and you write it as one whole log. The second one is when you're dividing. So just like with exponents, when you're dividing, you subtract. When you're dividing with your log, you can break this up into two separate logs with the subtraction sign in between them. And then this one is really important whenever we're solving for time in, let's say, a financial equation. We need logs, and this is the property that helps us solve for that time. So when you have an exponent, log base b of m raised to the r power, you can actually take this exponent and move it out in front, and this becomes r times log base b of m. And then the last two properties just say if your base and what you're taking the log of are the same. So remember when it was just written like this, we said this was 1. But then let's say you then have an exponent. Remember that exponent can come out in front. That would be x times 1, which is just x. And the other property says that if you have some number raised to a power where you have a log in that power and the base is the same as the number, so b raised to the log base b of x, this is just going to equal x. Okay, so let's use the property of logs to write as a single log. So right now I have two logs, and so I'm going to work backwards. The first thing I'm going to do is deal with this number in front of the logs. These can be written as exponents. So I'm going to move the 2 as an exponent and the 3 as an exponent. So I get log base 6 of 4 squared plus log base 6 of 2 cubed. Now that I've done that, I can deal with this addition sign. And remember, we said addition sign is the same thing as multiplication. So I'm going to write this as 1 log, so log base 6 of 4 squared times 2 cubed. So the addition became 1 log with multiplication. Now I'm going to simplify this. Log base 6, 4 squared times 2 cubed is 16 times 8, which is 128. And then just to remind you that a log is an exponent, what this would be asking me to solve, this is saying 6 raised to what power gives me 128. And that's a decimal. I would actually need my calculator to figure that out. But that's what this log base 6 of 128 stands for. Okay, in this other example, these two logs are in parentheses, so this 3 actually goes to both the u and the v. But I'm going to deal with the parentheses first, and subtraction means same thing as writing it as 1 log with division. So this would be log base 2 of u divided by v. And now I would deal with that 3, and that becomes my exponent. So it's u and v to the 3rd power. So you can write it in parentheses, or you can just make sure to put that exponent with both the u and the v. Either way would be fine. Okay, now I'm going to do the opposite. I'm going to go from 1 log and expand this out. So in this case, the first thing I'm going to do is deal with this multiplication and write this as log base 5 of x plus log base 5 of y to the 6th, because that 6 only goes with the y, it does not go with the x. And now I'll move that exponent out in front, so it'd be 6 times log base 5 of y. For b, I'm going to deal with the division. So this would be log base 3 of x minus log base 3 of y squared. And then again, I'll just move the exponent out in front, so it's 2 times log base 3 of y. And that's as simplified as this can get.